The learning objective is students will be able to estimate the limit of functions. Today we're going to be discussing determining the limit looking at a graph. Here you'll see a picture of a graph. This is a function, and we're going to determine whether the limit exists as x approaches 0 of this graph. So as you can see here, we have two horizontal lines, and we want to see if the y value as we approach x equals 0 from the right side will be the same thing as the y value as x approaches 0 from the left side over here. Now it may look pretty obvious on this example that they will not be the same. So as you can see here, you can see that the y value stays the same even as the x value decreases, and as we get closer and closer to 0, you can see here that it's actually undefined, and you can see there that there is no point as noted there with the open circle, or what's known as an open circle. It's not filled in, and here you can see the circle is filled in, which means that the y values are defined. Okay, so notice here we're doing the same thing as we approach from the left side, and on the left side you can see that the y value approaches -1, and the left and the right side do not equal each other. So on this specific function, the limit will not exist. Moving on to the next graph, on this function here, it appears to be just an ordinary line. Okay, so let's suppose I wanted to determine the limit as we approach x equals 0 here. As I start to look at the y values, you can notice that the y values are getting closer and closer to a specific y value as x approaches 0 from the left. Okay, so you may see here, as you can see, it approaches y value of 2, and then we did the same thing from the right side as x approaches 0. You can see here that the y values are decreasing, and it's approaching a y value of 2, and you can see here by the filled in circle that it is defined, and the limit does exist as x approaches 0. Let's see if we were to look at x approaches -1, looking at the exact same graph. So we're now approaching x equals -1, and we're getting closer and closer, and it looks like the y value is going to get closer to 1. Okay, and then we passed it here, so it may help to zoom in a bit. So we zoom in here. So as we're getting closer and closer to x approaches -1, again you see that the y values are getting closer and closer to 1. And then let's see. Oh, there it is. So as x approaches -1, you can see that there actually is no point there. It's undefined. But in terms of the limit, as we approach the x value here from the left side, you can see that it's approaching the same y value of 1. Okay. So looking at this function here, we want to see what the limit would be as x approaches 0. So looking from the right side, so x approaching 0 from the right. Okay, so we're getting closer and closer to x approaching 0. You can start to see that the y values start to increase. Okay, so we're going to zoom out a bit. Okay, here you see that the y values are increasing quite a bit. Okay. So if we zoom in, we'll continue to scroll up, you can see the y values are increasing, and what ends up happening with this graph or this function is that the y values are going to increase unbounded. So these y values will not stop increasing. Say that the limit does not exist in this case, since the y values continue to increase unbounded. And then moving on to the next function, we're looking at a curve. Okay, now here as you look at this curve, it looks like each of the points are defined. Here you could already see that some of the points exist. Okay, so we're going to want to see what happens if the limit of this function exists as x approaches 0. Okay, so here we're going to zoom in a little bit here to see more accurately what happens as x approaches 0 here. Okay, so here, just like before, we're going to look from the left side. Okay, so you can see here that the y values are increasing and they're getting closer and closer to 1 by the looks of it. Okay, so here you can start seeing that it's equal to 1, but here you can see that it's undefined. There is no point there that exists. However, if we're talking about the limit, we're not too concerned about if it's defined. All we care if the y values are approaching the same numerical value from the left side of x equals 0 and from the right side. So here you could see that the y values again are approaching 1. So here to this graph or function, the limit does exist and it's equal to 1. Okay, now that we've gone over those examples of determining the limit of a function by examining its graph, you're going to go ahead and do these questions for a quiz. Okay, so on the very first question, you'll be determining the limit of this function here by examining this graph as x approaches 1. You'll then be determining the limit of this graph here as x approaches 0. Next, you'll be determining the limit of this function as x approaches 0 as well. And then that graph should look pretty similar to something you saw earlier, and as well you'll be determining the limit of that function as x approaches 0. And lastly, you'll be looking at this function here and determining the limit if it exists as x approaches 1.